The Fibonacci sequence is a sequence of numbers where the starting values are 0, then 1. Then the third, fourth and fifth to nth terms can be found by adding the two previous terms in the sequence. Therefore, the Fibonacci sequence can be written as a second-order linear autonomous difference equation. The squares, cubes and successive powers of the terms in the sequence are known as Fibonomials and also have interesting properties that can relate to the original sequence. For example, if we construct squares with the width of the Fibonacci numbers, the squares fit neatly together to make a rectangle. As more squares are added, the ratio of the sides of the rectangle approach the golden ratio, an irrational number denoted by the symbol phi. This is because the ratio of two successive Fibonacci terms accurately approximates the golden ratio as the terms become arbitrarily large. The ratio appears again and again in nature and geometry. The Fibonacci sequence is also found when you take the sum of the oblique diagonals in Pascal's triangle.
Leonardo of Pisa was an Italian mathematician around at the turn of the 13th century. He went by many names but is commonly known today as Fibonacci. In 1202 he wrote Libera Bacci, or the Book of Calculations, which popularized the use of the Hindu-Arabic number system which we still use to this day. To explain this new system to Italian merchants, he described the breeding habits of immortal pairs of rabbits. The rabbits take 1 month to mature and can only birth another single pair at a time. Starting with one initial infant pair, who then take 1 month to mature. At the start of month 3, they give birth to another pair. At the beginning of month 4, the initial pair breeds again while the second pair matures. In month 5, the first 2 pairs breed, whilst pair 3 matures, giving us the numbers of the Fibonacci sequence.
The main applications of the Fibonacci number are in computer science. It's important in the computational runtime analysis of Euclid's algorithm in finding the highest common divisor of two numbers. The worst case for Euclid's algorithm are two consecutive Fibonacci numbers. As this is the worst case, it takes the most number of steps to find a result. Therefore, two Fibonacci numbers are suffice to show that the number of steps in Euclid's algorithm can never be more than 5 times the number of its digits. The Fibonacci search technique is a method of searching a sorted array using a divide and conquer algorithm. This method leads to about 4% more comparisons than a typical binary search. A binary search uses a division operator to divide range, whereas a Fibonacci search uses addition and subtraction. The Fibonacci number is also naturally occurring. The bee ancestry code. If an egg is laid by an unmated female bee, then it hatches into a male bee, but if the egg was fertilized by a male, then it hatches a female. If the ancestry tree of any male bee is followed, it will show that the sequence of parents follows the Fibonacci sequence. 1 parent, 2 grandparents, 3 great-grandparents, 5 great-great-grandparents, etc. This is similar to the human X chromosome inheritance tree, with the male only receiving an X chromosome from the mother and the mother receiving an X from both the male and female parents.